radioactivity. Sources of radioactive substances. Alpha particles, we have americium-241, beta particles, strontium-90, and then gamma rays, we have cobalt-60. Now, what are some of the properties of alpha particles, beta particles, and gamma rays? Alpha particles are positively charged, beta particles are negatively charged, and gamma rays are electrically neutral. Okay, so we have this particular table that is showing some of the properties of alpha particles, beta particles, and gamma rays. Okay, so the identity of alpha particles is that they are identified as helium nucleus because they have 2 protons and 2 neutrons. Okay, beta particles, they are identified as fast moving electrons, whereas gamma rays, they are identified as electromagnetic waves. Okay, relative charge. Okay, what is the relative charge on this particular radioactive substances? So alpha particles have got a relative charge of positive 2, beta particles negative 1, and then gamma rays have got no charge. They are electrically neutral. Okay, so relative mass of this particular radioactive substances, alpha particles have got a relative mass of 4 atomic mass unit, whereas beta particles, they have got a relative mass of 1 over 1800. Okay, 1 over 1800, which is a very relative small number, whereas gamma rays, they do not have any mass. The mass is 0. Okay, so the ionization effect of alpha particles is that they are very strong, beta particles weak, gamma rays very weak. Penetration power. Okay, so the ability of these particular substances to pass through certain materials. So we have alpha particles having the weakest, followed by beta particles, which has a greater penetration power as compared to the alpha particles, and then the gamma rays have got the strongest, such that even lead cannot be able to absorb these particular waves. Okay, the behavior in electric and magnetic field. Okay, alpha particles are deflected by electric fields. Even beta particles are deflected by electric fields. Gamma rays are not deflected by electric or magnetic fields. Okay, now what is going to happen if we make these radioactive substances pass through a magnetic field? What we're going to see is that the alpha particles and the beta particles are going to be deflected. Okay, with the alpha particles being deflected less, and then the beta particles being deflected the most. Why? Because the beta particles have got a high mass as compared to that of the alpha particles. And in case of the gamma rays, we are going to see that these gamma rays are not going to be deflected because they are not affected by magnetic fields. So this is how it is going to happen. Okay, so now what is going to happen if these electromagnetic substances are made to pass through an electric field? So we are going to have a situation where the alpha particles and the beta particles are going to be deflected, with the alpha particles being deflected to the negative side of the electric field because they are positively charged, because positive and negative, they attract. Then the beta particles are going to be deflected to the positive because they are negatively charged. Then the alpha particles, the gamma rays, they are going to move in a straight line. They are going to continue moving in a straight line because they do not have any charge such that they can be attracted to either the positive or the negative part of this particular electric field. Okay, so that's about this particular lecture that we had. So exercise. Okay, so list at least 3 properties of gamma rays, alpha rays, and beta rays. Start 1, source of gamma ray. And then The last but not the least is to distinguish the alpha particles from beta particles. Okay, so these are the three questions that you're going to attempt. Okay, subscribe and click the notification button such that you are able to receive notification whenever I upload a video on my YouTube channel, and make sure that you give it a thumbs up if you like that particular video. Okay, see you in the next lecture, and wishing you all the best in your exams.